So back to finish off this example, we've dealt with the situation of adding NH3, removing H2, and increasing the temperature. For a decrease in temperature, we're going to shift to the cool side of the reaction, the endothermic side. Well, as we discussed with the increase in temperature, when the heat is given inside the chemical reaction, that is the exothermic side. That is the warm side. The opposite side is then the cool side. So if we decrease the temperature, as always, the system will want to shift to minimize that stress. It will want to warm up. So we will shift to the right. By shifting to the right, all the substances on the right will have their concentrations increase. That is NH3 in this case. And all the substances on the left will have their concentrations decrease, the N2 and the H2. Temperature, again, is the only stress that will cause the value of KEQ to change. And since we're shifting to the left, since we're shifting to the right, that is, the KEQ will increase. Pressure changes. Pressure only affects gases, so we just need to count how many moles of gas we have. Well, on the left we have 1 mole of N2 as gas, we have 3 moles of H2, so we have 4 moles of gas total on the left. On the right we have 2 moles of NH3 as a gas, 2 moles of gases. An increase in the pressure will cause the system to shift to the side with the fewest moles of gas. That would be the right side. A shift to the right causes all those substances on the right to have an increase in concentration. That would be NH3. And all the substances on the left will have their concentrations decrease. That's the N2 and the H2. And again, as temperature changes are the only changes that affect the value of KEQ, a pressure change will have no effect on KEQ. The exact opposite stress, a decrease in pressure, will cause us to shift to the side with the most moles of gas. That would be the left side. A shift to the left will cause those substances on the left to have their concentrations increase. The N2 and the H2 will increase. Substances on the right will have their concentrations decrease. That's the NH3. And again, since this is not a temperature change, KEQ will not change. Last example, a different chemical reaction. I've already completed the table for removing H2. H2 is on the left. We're going to want to minimize that stress, so we're going to want to replenish the H2 that we removed, meaning we'll shift to the left. Since we have actually physically removed H2, its concentration decreases. Other substances on the left will have their concentrations increase. That's the I2. Substances on the right will have their concentrations decrease. That's HI. And again, no temperature change, so no change in KEQ. So, finishing off the table, if we add H2, we shift to minimize that stress. We're going to try to use it up. H2 is on the left. We're going to shift to the right to use that up. Now, we've actually physically added H2, so its concentration will increase. I2 being on the left will have its concentration decrease. HI being on the right, concentration will increase. And no change in KEQ since this is not a temperature change. If we add I2, again, substance on the left, we're going to try to minimize that and use that up. We'll shift to the right this time. Since we are shifting to the right and H2 is on the left, its concentration will decrease. We have actually added I2, so its concentration will increase. We are shifting to the right, so the concentration of HI increases. And again, no change in KEQ because there's no temperature change. We can remove some I2. Substance on the left, we're going to try to create more of it since we removed it. So to create more of that, we need to shift left. Shifting left, the substances on the left will have their concentrations increase. That would be H2. I2 will actually decrease since that is what we removed. HI, being on the right, will also have its concentration decrease. And no temperature change means no KEQ change. Removing HI, we want to try to replenish that and make some more of it. To do that, we need to shift to the right. Shifting to the right again causes substances on the left to have their concentrations decrease, H2 and I2 both. We have actually removed HI, so its concentration automatically decreases. And no temperature change means no KEQ change. Last two stresses are temperature changes. For temperature changes, we need to know where the heat is. The heat being present on the left side means that the left side is the exothermic or the warm side. The right side is the endothermic or the cool side. If we increase the temperature, we will want to cool off the system, so this system will shift to the right. By shifting to the right, the substances on the left, concentrations will decrease, H2 and I2. Concentration of HI, being that it is on the right, will increase. And since this is a temperature change, KEQ will actually change. It will increase since we are shifting to the right. A decrease in temperature will have the exact opposite effect. We decrease the temperature, the system will want to warm up, it will want to shift to the exothermic side, it wants to shift to the warm side. There are a lot of different ways that I can say this. We will shift left no matter what. A left shift means the substances on the left will have their concentrations increase. That would be H2 and I2. Substances on the right, concentration will decrease. That's only HI. And a shift to the left means that the value of KEQ will decrease. Now one last thing, I have not actually given any pressure changes or volume changes as stresses on this system because they don't matter. If we look at the left side, we have 1 mole of H2 gas, 1 mole of I2 gas. That will be 2 moles of gas. On the right side, we have 2 moles of HI, 2 moles of gas. Since we have equal moles of gas, pressure changes will have no effect on this system.